According to the National Electrical Code, for a 200 amp subpanel fed with copper conductors and polyvinyl chloride conduit, you will need 2 3/0 American wire gauge copper conductors for the hot legs. You will also need 1/0 American wire gauge copper conductor for the neutral leg. The neutral conductor must have an ampacity equal to or greater than the hot conductors. The American wire gauge, often abbreviated as AWG, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The larger the AWG number, the smaller the wire diameter. For example, a 24 American wire gauge wire is smaller than a 12 American wire gauge wire. The gauge is determined by the cross-sectional area of the wire, which dictates its current carrying capacity. Larger wires, with smaller AWG numbers, can carry more current without overheating. Wire gauge is important in electrical wiring to ensure that wires are not overloaded, which could cause a fire. The National Electrical Code provides tables and guidelines for selecting the appropriate wire gauge for different current levels and applications. These guidelines take into account factors such as the type of insulation, the ambient temperature, and the number of current carrying conductors in a conduit or cable. It's crucial to adhere to the NEC and local electrical codes when selecting wire gauge to ensure the safety and reliability of electrical systems. When referring to wire sizes, it's common to use terms like 14 American wire gauge, 12 American wire gauge, 10 American wire gauge, and so on. These numbers represent specific diameters and ampacities, and they are essential for electricians and electrical engineers to understand. Larger wires, such as 4/0 American wire gauge, are used for high current applications like service entrances and subpanels. A selection of the correct wire size is crucial for preventing overheating, voltage drop, and potential fire hazards. Always consult the NEC and local codes to ensure compliance and safety. Polyvinyl chloride conduit, commonly known as PVC conduit, is a type of electrical conduit made from polyvinyl chloride, a durable and versatile plastic material. It's widely used in electrical wiring for its protective properties and ease of installation. PVC conduit is designed to encase and protect electrical wires and cables, shielding them from physical damage, moisture, and corrosive elements. It's commonly used in both residential and commercial applications, providing a safe and organized pathway for electrical conductors. One of the key advantages of PVC conduit is its resistance to corrosion, making it suitable for use in damp or corrosive environments. It's also lightweight and easy to cut, bend, and join, simplifying the installation process. PVC conduit is available in various sizes and types to accommodate different wiring needs. It's typically installed with PVC fittings and connectors to create a continuous, enclosed raceway for electrical conductors. The use of PVC conduit helps to ensure the longevity and reliability of electrical systems by protecting wires from damage and environmental factors. It also provides a neat and professional appearance, keeping wires organized and out of sight. When installing PVC conduit, it's important to follow the manufacturer's instructions and local electrical codes to ensure proper installation and safety. This includes using appropriate supports, connectors, and sealing methods to maintain the integrity of the conduit system. Overall, PVC conduit is a cost-effective and reliable solution for protecting electrical wires and cables in a wide range of applications. It's a staple in the electrical industry, providing a safe and organized way to route and protect electrical conductors. Always consult the NEC and local electrical codes for specific requirements and guidelines regarding the use of PVC conduit in electrical installations. The hot leg refers to any energized conductor within an electrical circuit. In a typical single-phase 120/240 volt system, there are two hot legs, each carrying 120 volts relative to the neutral conductor. These hot legs provide the electrical potential needed to power various loads such as lights, appliances, and equipment. In a three-phase system, there are three hot legs, each carrying a specific voltage depending on the system configuration, such as 208 volts or 480 volts. The hot legs are typically identified by colored insulation such as black, red, or blue, to distinguish them from the neutral and ground conductors. It's crucial to handle hot legs with care, as they can pose a shock hazard if touched directly. Always energize circuits before working on them to prevent electrical accidents. The neutral leg, on the other hand, is a conductor that carries current back to the source, completing the electrical circuit. In a typical 120/240 volt system, the neutral conductor is grounded at the service entrance, providing a reference point for the voltage. The neutral conductor is typically identified by white or gray insulation. It's important to note that the neutral conductor is not always at zero potential, as it can carry current and develop a voltage drop, especially in unbalanced circuits. Proper wiring and grounding practices are essential to ensure the safety and reliability of electrical systems. Always consult the NEC and local electrical codes for specific requirements regarding hot legs, neutral conductors, and grounding. In electrical wiring, ampacity refers to the maximum amount of electrical current, measured in amperes or amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the size and material of the conductor, the type of insulation, the ambient temperature, and the number of current-carrying conductors in a conduit or cable. The NEC provides tables and guidelines for determining the appropriate ampacity for different types of conductors and wiring configurations. These tables take into account the factors mentioned above to ensure that conductors are not overloaded, which could cause overheating, insulation damage, and potential fire hazards. It's crucial to select conductors with adequate ampacity to safely carry the expected current load in an electrical circuit. The overloading conductors can lead to dangerous conditions and should be avoided at all costs. When determining the ampacity of a conductor, it's important to consider any applicable directing factors. Directing factors are adjustments to the ampacity based on factors such as ambient temperature, the number of current-carrying conductors, and the type of installation. These factors can reduce the ampacity of a conductor, and it's essential to account for them to ensure that the conductor is properly sized for the application. Always consult the NEC and local electrical codes for specific requirements and guidelines regarding ampacity and directing factors. Proper conductor sizing and ampacity calculations are essential for the safety and reliability of electrical systems. It's also important to consider the voltage drop in a circuit, as excessive voltage drop can affect the performance of electrical equipment and appliances. Selecting conductors with adequate ampacity and minimizing voltage drop are key considerations in electrical wiring design. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician if you're not comfortable performing electrical tasks yourself. Electricity can be unforgiving, and it's important to take all necessary precautions to ensure your safety and the safety of others. Be sure to check local codes and regulations for any additional requirements that may apply to your specific situation. Local codes may have additional requirements or restrictions that are not covered by the NEC. It's important to be aware of these local codes and regulations and to comply with them. Copper conductors are typically more expensive than aluminum conductors, so factor in the cost difference when making your decision. Copper is a better conductor of electricity than aluminum, but it's also more expensive. Aluminum is a lighter and more cost-effective option, but it's not as good of a conductor. Properly size and install all conductors according to the NEC and manufacturer's instructions for safe and reliable operation. This is the most important thing you can do to ensure the safety of your electrical system. The NEC provides detailed guidelines for sizing and installing conductors, and it's important to follow these guidelines carefully. The manufacturer's instructions also provide important information about the proper installation of conductors. Failure to follow these guidelines can lead to dangerous conditions and potential fire hazards. When working with electrical wiring, it's important to take all necessary precautions to ensure your safety. Always to energize circuits before working on them, and use appropriate personal protective equipment such as gloves and safety glasses. If you're not comfortable performing electrical tasks yourself, it's always best to consult with a qualified electrician. Electricity can be unforgiving, and it's important to take all necessary precautions to ensure your safety and the safety of others. Remember to always prioritize safety when working with electricity. Always turn off the power at the breaker before starting any electrical work. Use insulated tools and wear appropriate safety gear, such as gloves and safety glasses. Double check your work to ensure that all connections are secure and that wires are properly insulated. If you're unsure about any aspect of the electrical work, consult with a qualified electrician. Electricity is a powerful force, and it's important to respect it. By following these safety precautions, you can minimize the risk of electrical accidents and injuries. In addition to the information provided, it's also important to consider the specific application and environment when selecting conductors for subpanel. Factors such as the type of loads being served, the ambient temperature, and the presence of corrosive elements can all affect the performance and longevity of electrical conductors. For example, if the subpanel is serving heavy loads such as power tools or electric vehicles, it's important to select conductors with adequate ampacity to handle the increased current demand. Similarly, if the subpanel is located in a hot or humid environment, it's important to select conductors with insulation that is rated for high temperatures and moisture resistance. In corrosive environments, it's important to use conductors with corrosion-resistant coatings or materials to prevent premature failure. By considering these factors, you can ensure that the electrical system is safe, reliable, and durable. Always consult with a qualified electrician or electrical engineer to determine the best conductors for your specific application and environment. They can help you select the right materials and sizes to meet your needs and ensure compliance with all applicable codes and regulations. Remember that electrical work can be complex and dangerous, and it's always best to seek professional help when you're not sure what to do. Your safety and the safety of others depend on it. In summary, for 200 amp subpanel fed with copper conductors in polyvinyl chloride conduit, you will need 2 3/0 American wire gauge copper conductors for the hot legs and 1 American wire gauge copper conductor for the neutral leg. The neutral conductor must have an ampacity equal to or greater than the hot conductors. Be sure to check local codes and regulations for any additional requirements. Copper conductors are typically more expensive than aluminum conductors, so factor in the cost difference when making your decision. Properly size and install all conductors according to the NEC and manufacturer's instructions for safe and reliable operation. Always prioritize safety when working with electricity and consult with a qualified electrician if you have any questions or concerns. Electricity is a powerful force, and it's important to respect it. By following these guidelines, you can ensure that your electrical system is safe, reliable, and efficient. Remember to always double-check your work and test all circuits before energizing them. This will help to prevent accidents and ensure that the system is working properly. If you encounter any problems, consult with a qualified electrician to diagnose and repair the issue. Electrical safety is paramount, and it's important to take all necessary precautions to protect yourself and others from harm. By following these guidelines and seeking professional help when needed, you can ensure that your electrical system is safe and reliable for years to come.